what we are going to kaitkan for today's session lah ya. Let me share my, I'm using my screen lah now. Okay. So today we are going to further discuss on the what we call association rule mining. Yeah. Let's swap. Okay. Let me record as well. Recording. Okay. Okay. So this is something that we have discussed last week. Alamak, kiri tak nak bergerak. Okay, and then sorry. Sekejap. Stop. Sorry, I kena stop sekejap. Ni tak boleh share to that one. I have to use my okay, this is what we have discussed. So to the association analysis, something that related to unstructured data, and especially when we have what we call databases in the form of transactions. Yeah. Which could, why unstructured? Because we can see here the data, different items occur in different transactions. Yeah. And the important process involved in this algorithms or methods will be, first, find frequent patterns, and second will be the association rules. Okay, and this will be reflect to the measures that we are going to use, which is first for the patterns item set, we use support. Okay, and support is the probability. Actually, it's a probability total records with the items divided by total of transaction. Okay, meanwhile for association we use confidence. Yeah, means that we are looking at how many the left hand side occurs with the right hand side. So this would be can be calculated using support of items or the item sets, yeah, divided by support of the antecedent. Okay, so other than that, it could be you use leaf value for determine the best rows. Okay, so in a priori what we have done is that the process involve what we call the golden rules. Yeah, the golden rules of a priori what we call algorithms, which is using the methods of candidate generation and test. Means that we have to iterate the process by determining firstly what is the candidate for one item. Okay, and then we have to look at the transaction whether the items occurs. Okay, and if this is the golden rules for the a priori, if the item set or any item set which is infrequent, its superset should not be generated. Okay, so if the subset like A, B, C do not occur, so A the superset of A, B, C cannot occur, or A, B cannot occur. Yeah. Okay. The thing is that if you look at the a priori concept, it involve multiple scanning. Yeah. So after one iteration, okay, we have get the candidate, and then it have to be tested in the database to check whether whether the items occur in the data set or not. So this will be the for iteration one, for example, this is the frequent items found, and then from this we generate the two items set, and then we test, okay, and then we check This is the final output from iteration 2. And then from this 2 item set, we generate the 3 item set, candidates of 3 item set, and then we check, and this is will be the final. Okay, remember why BCE? Yeah, only BCE occurs because BCE is the superset. And what are the subset of BCE? The subset of BCE, BC, BE, and CE all occurs. Yeah, all occurs as frequent. Okay, and then it actually we can have a combination of A, B, C, but it cannot be generated as candidate because A, B, C. Yeah, what are the subset of A, B, C? We have AC and we have BC, but AC is not occur. So the combination of A, B, C would not becomes the candidate of 3 item set. Okay, so this will be the a priori. As you see, the a priori have to scan the database and then work to the what we call testing process multiple times. Okay, and this will be the confidence that used to determine the to determine the association root the highest the highest values or confidence that will be more than minimum confidence will be generated as association rules. Okay. I hope that you have done this this exercise to find the confidence. Okay, and then group group A and C have gone through the lab exercises. So we have looked at this example. Okay, group B will be this afternoon. Okay, the problem with a priori, this will be the problem of a priori. Okay, so today I'm going to discuss with you the other approach or the other algorithm that can help reducing the process of scanning. And here let me introduce to you. Okay, right, will be okay. So I'm nampak ya screen yang ini? Nampak kan?
Nampak.
Hello?
Nampak,
Okay.
nampak.
Okay, so this is the screen. This is the another algorithms, what we call as the frequent pattern growth. Okay, so this algorithm is been proposed by Jue Han. If you remember the book that I have shared in the beginning of the semester, which is Data Mining by Jue Han. So buku tu sendiri apa nama? Yes, Jue Han considered as Sifu of data mining, and this is one of the algorithm that been being developed ataupun the algorithm that been proposed by Jue Han. Okay, right. Please have a look at the process involved in the frequent pattern growth. Yeah, the basic process will be the same. Means that first process will be find frequent patterns and then generate roots. Okay, but if you look at the process here, okay, the activity will be different. Yeah, first the activity involve constructing the frequent pattern tree and then mine the frequent pattern tree. Okay, so two sub process for the frequent patterns. Okay, remember in April just now I mentioned the process will be generate the candidates and then test. Okay, and then you would have the frequent patterns or frequent item sets. So here the different would be you can see the different sub process involved in the frequent pattern growth here. And yeah, the second step will be generate rows will be the same. Yeah. Okay, and what will be what we will see in the frequent pattern growth will be how the algorithm uh, uh, producing the frequent patterns without the generation. Yeah, so here is a breadth first. That is will be the problem with the a priori is a breadth first, means that it goes to level and level and generate the item set. So here we are going to apply what we call as the depth first. Yeah, right. Wait, let me have a look at it. All right. Okay, so that first search, yeah. So and major personalized. Okay, this one definitely we could see that the item sets can be produced through, yeah, through ini saya akan explain sikit nanti later on, through what we can see in the branches of the tree, yeah. Okay, the idea, okay, this part you can see it. Okay, what are the method, I mean, when we referring to the frequent pattern growth, yeah, what are the processes? Yeah, definitely it involves, yeah, first is uh, constructing the tree. Okay, and then we repeat to look at the conditional of the tree, yeah, and um, uh, this path will be determining the what we call patterns that frequently occur. Definitely when we construct the tree, it will eliminate those items which are infrequent. Okay, so this will be the beauty of frequent pattern growth. Yeah, at the beginning, it will identify, or what we call it will focus on items. Yeah, items or variables that frequently occur in the database. Okay, how we are going to do, how it it shows like how the process, yeah, how it, I mean, saya rasa saya ada tinggal satu. Okay, tak apa. Okay, right, so let's have a look at the tree. Yeah, the first process here given to you. Yeah, given to you, there is a data set, yeah, here. Okay, and then how many transaction that you see in the data set? How many transactions?
9.
9.
Nine. Okay, right, good. Okay, and then here, if you look at the list of items, yeah, what are the list of items that can be found? Apa dia? You have?
I1
Okay,
I1
1.
I
okay,
I1
you
L.
betul I.
Ah.
Okay, so I1, and then we have I2, and then we have I3, I5, I4, I3. Betul tak? Ada lagi tak? Tak ada kan? Okay, so these are the all items that can be found in the data set. Okay, the first scanning is actually, okay, what it did was, yeah, it goes to the transaction, okay, and then it capture, yeah, it capture the items in the transaction, and in the temp array ataupun in the temp memory, it will count this item. So for transaction 100, yeah, definitely item 1 is found one time, and then item 2, the count is equal, oh sorry, 1. Okay, and then item 5 equal to 1. Okay, when it goes to the transaction 200, apa yang berubah? What have changed? Apa yang berubah? I1 lagi?
I2 2.
Okay, thank you. I2 equal to 2, and then I4 equal to
1.
1, and then I5 equal to 1. Okay, so yang berubah cuma I1, I2, and we have another item included in the array, which is I4. And then it goes to the T300. Okay, T300. So I2 is bertambah. Okay, and then we have I3. So a new item is included in the array. Okay, and then we look at T400. I1 is increase plus 1. Okay, so means that we have I1 equal to 2, and then I2 equal to berapa tadi? 4 lah. Yeah. Okay. And then I5 equal to, sorry, I4 equal to 2. Okay. And then I5 equal to 1 and I3 equal to 1. Okay. It goes to the fifth transaction. Okay. So I1 equal to 3. Okay. And then I2 equal to 4. I3 tadi ada 1. So tambah lagi 2. Tambah jadi 2. And then it goes like that. And then what we what is the output of this iteration would be the what we call as a header table. Okay, and the header table include the items and the count of the items. And remember here another point is that any what we call items less than 2 will not included in the header table. Okay, so now if you see I1, I2, I3, I4, and I5 all are inclusive in the header table. In case, for example, you have I6 and I6 only occur here, means that it occur in one time. So this item will not included in the header table. Faham? Faham tak? Yeah. Okay, so maksudnya you have to remember inside the header table is only those items that will be more than the support count. Okay, so this will be very important because from here we want to construct the tree. Okay, and we have to retain those items would be the frequent item only. Yeah. Okay, so this will be the first step of the frequent pattern growth, right? Okay, next we go to the second, before that, we have a look at here, okay? Another point is that you need to look at how the sorting done, how the sorting done in the header table. The sorting is been done through the count itself, means that the highest count will be at the beginning, okay, and the lowest will be the last. Why it has an implication if the sorting is not based on the count, it will implicates to the tree that we are going to develop. So remember, tree we have branch and then we have root, which is actually a prefix and suffix. Yeah, if you remember, tree itu ada prefix and it has suffix, which is prefix will be the conditional and the suffix will be the leaf. Yeah. Okay, now let's have a look at this. Okay, after you have the header table, what we are going to do is that to doing the sorting for the items. Yeah, for the items for each transaction. Okay, so the setup will be done based on the frequency. If you look at the the transaction 1, okay, it been started from I2, I1, and I5. Yeah, because I2 first, and then I5, and then barulah I1, sorry, and then lastly will be I5. And same goes to the second transaction, I2 and I4, and then I2 and I3, yeah. And then this one also change the sorting, which is I2 and I1, and then I4. Okay, and this will be retained, this one will be retained, this will retain. Okay, this one will be changed here. So I2, I1, and I3, and I5. And finally also will be changed to I2, I1, and I3. Okay, clear about this? Faham, eh? Okay, all right. Okay, next. We are going to construct the tree. Okay, actually I tried to put it into the whiteboard tapi tak berjaya. It's okay. So in the slide also contain some kind of animation. Okay, I hope you can follow the transaction. Let me do. Okay, here. Okay, right. Okay, let me do with you. Yeah, for this part. Okay. Now, what we are going to do is that first, in the transaction, in the constructing the tree, yeah. First, we are going to create a root which is known as now. Okay, ada pencil tak sekarang? Ada kertas tak sekarang?
Ada.
Okay, so buat sekali dengan saya. Okay, so now, okay, this is now. Okay, and then we are going to scan the database, the sorted database. Apa nama? We are going to scan the sorted database. Okay, another time. So we start with now. Okay, we start with now. Okay, and then it goes to the second, the first transaction. Okay, first transaction, and then we are going to represent the items as a node. Okay, so now we have a node of I2. Okay, and also there will be another information attached to the node, which is the count of the item. Okay, so we are visiting transaction 1, so the count for I2 equal to 1. Betul tak? Okay, and then what will be the next node? Kat sini node apa?
I1.
Okay, thank
I1.
you. I1. Okay, with the support value of 1. Betul tak? Okay, next.
I5.
Next. Okay, good. I5 with the transaction, with the support value at 1. Okay, so next. Okay, we finish this one. Okay, so now it goes to the transaction 200. Okay, so transaction 200, we have I2 and I4. So how you going to draw, how you are going to add the items and the branch in the tree?
Under null.
Under null, lepas tu?
Tambah ke I2 satu lagi. So I2 tu akan jadi 2.
Betul, pandai. Okay, so kat sini kita akan, okay, so di sini akan jadi berapa? 2. Okay, and then there is no I4 here kan? Betul tak? Okay.
Yes.
Okay, then you have to add a new node. Yeah, add the new branch, which is this is I4 with support value of 1. Boleh? Okay, cuba continue dengan T300. T300. Macam mana you dapat?
Dia akan keluar lagi satu node I3.
Good. Alright, so this is becoming 3. And then we have another node here. Alamak, tak cantiknya node saya punya branch. Okay. So this is a new node, a new branch of I3 with support of 1. Okay, boleh eh? Okay, next. Aduh.
I2 tu tambah. Jadi I4.
Okay, betul. Okay, ini jadi 4. And then ini jadi berapa?
2.
Okay, ini jadi 2. And then we
Satu
have
keluar lagi satu node.
okay, betul. So ini I4. Berapa kat sini?
1.
Okay, 1 eh. So this one is done. Okay, T500.
Dal ke I1.
Bagus. Maksudnya kita buat lagi satu branch bawah null bukan dekat sini not this one. Okay, so you should have a new branch because the prefix is not same. So yang ini sebelum ni semua prefix dia adalah I2. Okay, so this one the new prefix. So it should be I1 here. This count of 1 and then we have I3. This count is 1. Okay. So add this one, okay. So the next one is here, jadi 5. Okay, and then you have here, another jadi 2. Boleh? Okay, 700. 700 akan berada di mana?
Dia akan tambah I1 dengan I3.
Good. Okay, here is becoming 2. Okay. And then T300 would be this one becoming 6. Okay, and then it goes to I1 here is becoming 3. And then it goes to a new I3 equal to 1. And then you have another one node which is I5 equal to 1. Boleh? Okay.
Boleh.
Lastly, yang ini adalah this one becoming 7. Okay, and then this one becoming 4. And then I3 becoming 2. Tiada perubahan di I5 ataupun di prefix, di suffix. So done this one. Okay. Boleh dapat yang ni? So this is what we call as the tree. Yeah, FP3, frequent pattern tree. Okay. So you can see it in the slide being explained. Yeah. So I don't have to read it out. Okay, you can just refer it later on. Yeah. We have done just now. I repeat it again. Okay. Now you have to construct it. We have constructed it. Okay. Now we are going to mine. Mine it. Okay, how we are going to mine the frequent pattern tree? As we see in the tree, it will be for each length of one pattern. For each length one pattern, ataupun we are referring to the suffix pattern, means that it should has a conditional of the for that particular what we call branch, which with a set of prefix. So suffix is the leaf. For we are going to look each of leaf that we have in the ataupun length of one of the pattern in the data set. And we construct what we call as we are going to construct the conditional of the suffix. Okay, let me show you in the more simpler words. Okay, right. So this one will be consider first. We are going to look at I5. Okay, where can you find I5? Okay, so I5 occurs here, I5 occurs here. Okay, so there are two branches involved for I5, which you can see what are the prefix of I5. Prefix of I5 or conditions of I5 are with I2 and I1. Okay, and another branch will be I2, I1, and I3. Will you follow? Okay, and then you bring the count of the branches. So here occur one time, and this one is occur one time. Yeah. Okay, next. Okay, so what we are going to do is that you have I5 here. Okay, and we put a conditional pattern base, for the I5, which is extracted from here. Okay, so what is the conditional is I2 and I1 with count 1. Boleh? Okay, and then the next one is I2. Oops. Okay, macam mana saya nak padam ni? Dia selalu terkeluar. Okay, so I2 and then I1 and I3. Okay, yang ini Another conditional pattern which is occur 1. Boleh? Okay, and now next one. Okay, we look at the conditions. What are the conditions? Just now we are looking at the conditional pattern. I mean, the suffix of the the prefix of I5. Okay, look at the items that occur here only. So what are the items occur here? Apa item yang occur di sini sahaja? Apa dia? Anybody? Apa dia?
I2 and I1.
Okay, good. Thank you. So sekarang ni let me use another pointer. Okay. So kat sini we have I2. Okay, I2 occur here and occur here. So we have another number here. I2 occur 2 times. Okay, and then we have I1. Betul tak? Okay, and we have I3. I3 berapa? I3 adalah 1. Okay, so remember the support count must be 2. So I3 will be prune. Okay, ini proses tapi if you put it into the algorithm, definitely these are becoming array. Temp array 1, temp array 2, yeah, temp array for conditional base, and then temp array for conditions of FP. Okay, now after that we have to append, we have to append what we call the items here, the conditions of the conditions and the items itself. Okay, so when we append it, it becoming what here? I2 lagi?
I1.
Append dengan yang ini. Append dengan yang ini. So dia jadi I2 and
I5.
Great. Okay. So when we append, we have to append item here with items that we look just now. Maksudnya kita tengok kepada prefix dia. So I2 and I5, the occurrence equal to 2. Okay. And then we append I1 and
I5.
Good. Okay. So occurrence equal to 2. Okay, faham? Okay, yang ini prune tadi kan? We prune because it lesser than minimum support. Okay, so you can see here the description of the processes lah Okay. Oops. Any question this part? Okay, faham So we have done on I5. We have done on I5. Okay. Next, we are going to look at, the next one we are going to look at. Okay, let's have a look at, okay. Let's have a look at another prefix, items, So next we'll be looking at the I4. Consider I4. Okay, boleh buat I4. Cuba you buat. I give you 1 minute at least. Okay, boleh? So I4, okay, what will be conditional for I4? It can be found in this branch and at this branch. Okay. Boleh dapat jawapan dia?
Dapat.
Dapat So you akan dapat only I2 dengan I4. Okay. So let me skip this part. Next, let's have a look at the next item, which is I3. Cuba buat I3 pula. Okay. So I3 ni you kena be careful sikit lah sebab kita nampak now we can see I3 occur here. Oops. Okay, occur here, here and here. Sekejap Okay, teruskan dulu. Okay. So we have I3. Okay, at the first branch, which is okay. For easier for you, kalau a tips for you, okay, a tips for you. If you have these different branches, probably you need to do it branch by branch lah, like this. One. Okay, and then we go to the next branch, which is I1.
Doktor nak tanya yang con FP3 tu macam mana dapat 4 dengan 2
Yang mana?
dekat con FP3 kiri dia.
Yang ini ke? Ni.
Step sebelum yang ni.
Yang ni sebab dia occur sini 2. I2 count dia 2. Okay, and then for the branch here dia ada 2 branch di sini, bahagian sini So this is 1. Nampak tak kat sini 2? This is 2. Kan? And then another one here. Ini pun 2. Okay?
Got
it. Alright, so the total of I2 di sini 2 plus 2, so it becomes 4 lah kat sini. Okay?
2 plus 2 equals to 4.
Boleh tak turing game?
Macam mana?
Boleh.
Okay, so I continue yang this one
Madam. Yang I1, I3 tu bukan 4 juga
Dia kira kat sini. So sekarang ni saya tengah buat yang bahagian ni lah. Okay. Let me padam dulu sekejap. Oops. Okay. So this is another branch. Let me change my color. Oops. Mana tadi? Okay. So this is I1. Ya, sini I1 equal to 2. So I2 equal to berapa tadi? Sorry. I1. So I1 and I3 equal to 2.
Doktor, memang kena kira asing lah kalau branch lain.
Tak, itulah saya bagi tips kat sini lah untuk memudahkan awak. For easier for you to get it. So now, okay, so now if you look at here, dengan ini, sama kan? So apa yang you boleh buat kat sini?
Tambah jadi 4.
Combine je lah, yes. So yang ini jadi, so maksudnya total dia adalah 4. Boleh Faham Boleh refer. Ada soalan di sini?
I2 dengan I1 tu dia tambah mana?
Yang mana?
Frequent pattern generator.
Frequent pattern generated ni.
Itu. I2, I1,
Ni?
I3.
Sebab kat sini kita ada conditions of I1 juga. Ni, nampak ni?
Nampak.
Kan? So, here in this array, we extract all items here. So, I2, and then we have I1. So, that's okay. Nak senang, let me show here lah. Sebenarnya benda tu reflect kepada apa nama? The what we call tree. So we have gone through here. What is the punya conditional? Conditional dia adalah here and here kan? I2 and I3. I2 and I1. So count dia lebih daripada 2. So definitely kat sini akan menjadi I2 and I1 as the conditions. And ada cara lah kalau you nak tengok. Boleh faham tak?
Boleh.
Kan? Okay, sama jugalah here. If I3 sahaja, what is the conditions? Conditions dia adalah I1 sahaja, only I1. So we can say that this is with the condition for this path and this path. So I2 will be 4. So that is what the meaning of frequent pattern generated would be what are the items, items that ataupun the item set that occur together. So I2 and I4 occur more than minimum support value, which is 4. Okay, it a priori is very direct, means that it's just scanning, but here we are looking at the tree. So if we are looking at the item 4, what will be other items together with I4? Okay, if you look at just now item 2, item 5, what will be the items that together with I5? So by using 3, actually we can dig or we can mine what are the items occur together through the branches. Okay, so this is what we have. What we have gone through. Okay, so please have a look at it. Okay, but here in the table nanti saya betulkan which one this part sebenarnya adalah 4 lah. Yeah, this one. Okay, nanti saya betulkan dalam YouTube, dalam future. Okay. Okay, next. Okay, can you do for this one? Can you do for I1? I1 occur dengan items apa? Only? I1 occurs with which items?
I2.
I2.
I2 only. Yeah, this one is not considered lah because this is null kan. So we look at the items occur with which prefix, yeah, or the corresponding prefix. So I2 only. So definitely you can see the outcome like this lah. Okay, oops, saya tak keluarkan lagi. Okay, ini. Okay. Okay. So only I2 occur together with I1 here. Okay, and then the count is 4 here. Okay, and then so we append, yeah, we append I2 with I1, then we get the frequent patterns. Yeah, we get the frequent pattern, which is I2 and I1 occurring with 4. Boleh?
Boleh.
Okay. So this will be after we combine all, yeah, the table will be looks like this. Okay, and these are, yeah, these are the frequent patterns generated. Okay. Kalau when for example in exam, yeah, sometimes students get confused. Okay, apa yang keluarkan ini saja. Okay, because this is the last items that been investigated. Actually, all of these are the frequent patterns.
Output.
So ini adalah output dia lah. Ya, betul. This is all the output. Okay. Or we can say that these are all the frequent patterns. So here, if you look at it in any suffix ataupun in any items that we investigate, we do not limit the study into the K, for example, equal to 2, yeah, K equal to 3. So by examining the branches, okay, and so forth, so we can get, yeah, the conditions, we can get the conditions, and it helps us to generate the combinations of item, yeah, whether they 2 items, 3 items, 4 items, and so forth. Yeah, right. So generating this will be actually terminate the process of finding frequent patterns, right? So what will be the next process? Apakah proses seterusnya? Apakah proses seterusnya? After you have generate these frequent patterns, what will be the next process? Atau what will be the next steps?
Generate rules.
Yes, good. All right. So next process will be generating the rules, and the rules will be from the frequent patterns. Yeah. Okay. For example, these are the items. Yeah, item set. I2 and I5, okay, and then I1 and I5, and so forth. Yeah. Yeah. So which rules will be generated? It should comply to minimum 70%. Okay. So the same process like what you apply in the apiary. Okay. The difference will be in the constructing the tree. So if you see that the frequent pattern growth will be quite efficient in representing the data into frequent patterns items only in the tree. So it shows what we call as the compactness. Okay, and then in terms of completeness, definitely it will go through all the branches that been presented in the tree, and then from that tree you can identify what be the conditions of each items or each suffix. Okay, and this will be the experiment and paper that been reported in the articles. Clearly it shows that when we compare between frequent pattern growth and a priori, it shows efficiency where comparatively to the runtime, frequent pattern growth will produce the item sets faster compared to the a priori. So a priori have to scan. It will be too much burden on the algorithm as to the computer especially, and also the memory. Okay, so I think that will be the summary of the frequent pattern growth. I mean, in terms of other applications of frequent pattern growth will be the same to the what we have discussed in the a priori algorithms, which will be it can be implemented in any application like documents in medical data set. Please have a check in the last slide. You can make a comparison in terms of looking how the process is being done in a priori, in frequent pattern growth using the same sample of data. Probably you want to try, for example, this data set, for this data set, okay, and then you want to test using a priori, so you can also try it. So the idea is that at the end, if you want to compare the output of a priori and output of frequent pattern growth, apakah yang what do you think that you will get? Is there any differences or is there any similarity for the output of frequent patterns from FP growth and from a priori? Anybody? Ada tak perbezaan ataupun persamaan output untuk frequent patterns daripada FP growth dan juga daripada a priori? Ada pendapat? Boleh jawab?
Kalau macam in term of efficiency, epigraph lagi efficient, kan?
Okey, betul. Tadi saya dah tunjuk sampel dia. Betul tu Irfan? Haikal? Haikal nak jawab apa?
Saya tak sure tadi. Saya nak jawab tu je.
Okey. Yang lain. Mana ni saya nak panggil? Yadi. Yadi? Yadi tak ada. Okey. Siapa nak panggil? Puteri. Puteri boleh jawab? What do you think? Ada tak persamaan ataupun perbezaan? Tak nak jawab juga. Okey, senyap je. Kita tanya orang lain. Ataupun ada sesiapa nak beri pendapat.
Macam kalau untuk last scale macam dia akan, kalau macam guna apa tu, yang epigraph more cakap kurang kurang error lah berbanding dengan a priori.
Okay, you boleh bercakap begitulah. Maksudnya error tu dalam konteks the use of memory lah kan, dia boleh generate to all ataupun dia boleh keluarkan output. Hasif, rules berbeza ke Hasif? Awak rasa berbeza ke? Ada pendapat lain tak? Cuba you buat exercise ni nanti You tengok Kalau you gunakan Aprary, you gunakan FP growth. Ada perbezaan tak? Ataupun you try to run dalam Weka tu. Ada beza ke tidak? So saya simpan jawapan tu untuk next week. So I hope that you can try it later on to see the difference ataupun the similarity of this outcome ataupun this output Okay, kalau tak ada apa-apa, I think that's all. Saya habiskan awal so that I leave you this time for you to allocate some time for the Kaggle session nanti So hopefully you can join the Kaggle session if you are available, whether tomorrow ataupun the next morning on Khamis So Wednesday afternoon or morning, Thursday morning. Boleh?
InsyaAllah.
InsyaAllah.
So kita jumpa
InsyaAllah.
dalam kelas yang itu So please if you cannot make it tak boleh nak attend full 2 jam, at least sejam to listen to it because it's very very related to you. It's about Kaggle data that you are going to most of you are using it for your project, and also it can be your next job for you you can form groups, you can form members of a certain competition, then that is open to anybody. You can attend or you can join the competition anytime, and it offer also grant. Maksudnya grant tu maksudnya kalau you join as a member and so forth, you are being funded to certain certain courses. Boleh So kita jumpa untuk sesi Kaggle at least separuh masa ataupun kalau penuh masa lagi bagus. Majid tua boleh? Majid, are you here? Tak ada? Okay, so I think that's all today. So hopefully you don't forget to fill in your future attendance. Kalau tak ada apa-apa, you may leave, or in case you have anything, I stay here. I'm around.
Okay, thank you,
Alright.
madam.
Thank you,
Okay,
Dr.
welcome.
Thank
Thank
you,
you, Dr.
Doctor.
Alright.
Thank you.